Alright, so I hope I'm recording. We've been taking a look at skill packet 5, which is exponential functions and logarithmic functions, and our test over that skill packet, why these are the solutions to those problems. Here for 4 problems, we have the same directions. They give us an approximation of log base a of 2, log base a of 7, log base a of 10, and they want us to find a numerical value for each of these using properties of logarithm. So I need to recognize that this is a product, and I can write a single logarithm as the sum of 2 logarithms with the same base. So I can rewrite this as log base a of 70 plus log base a of a squared. Now, my a's and my 2's look very similar, so I'll try to write my 2's a little bit different. Let's look at 70 and see if we can write 70 as a product of these values. Well, we see 7 and 10. So I can save a little bit of space and time to rewrite 70 as 7 times 10. And by the product rule, that's then log base a of 7 plus log base a of 10. Now here, this 2 comes down by the power rule as a coefficient, and log base a of a logarithm is an exponent, and a to the first power is equal to a, so this is just the number 1. So what we have here, log base a of 7, 1.590 plus 1.881 plus 2, and what do we get? I don't know what we get. Let's see. 1.59, 1.881 plus 2, 5.471. Alright, so I hope that helps, and I hope I didn't make a silly mistake. Let's move on to the next one. Here I have the log of a quotient, and by the quotient rule, I can write this as log base a of 8 minus log base a of a. Log base a of a I know is the number 1, and 8, I can rewrite 8 as 2 to the third power. So I have 2 to the third power minus 1. I've got the power rule that says that 3 can come out in front as a coefficient, and they've told me to estimate log base a of 2 as that decimal number. So 3 times 0.566 minus 1. If I do that, and hopefully don't make any mistakes keying this in, 3 times 0.566 minus 1. I get 0.698 there. Alright. Let's see what the next one is. Log base a of 1. Well, a to the 0 power is equal to 1. This logarithm is an exponent, so that's simply 0 because a to the 0 is equal to 1. Let's rewrite this as log base a of 7 to the 1/2 power. By the power rule, let's pull the 1/2 out in front as a coefficient, and they tell us what log base a of 7 is. They approximated it to be 1.590. So let's come in and take half of that. So if I haven't made any silly mistakes here, I'm getting 0.795. And that was it for that group. Alright, hey, I hope that helps, and I will talk to you later.